Hi everyone, hope you're doing well. This is a video to go over homework number 109. Please make sure you post it on Google Classroom so you get credit for it. Okay, so this homework was about other types of regression besides linear. We also went over exponential and quadratic. So for the first part, it says for each scatter plot, determine the best type of regression from linear, exponential, or quadratic. Draw a representative curve through the data. So usually, again, we don't really connect scatter plots, but for this example, we do. So we can see when we connect these dots, it's quadratic. This one is exponential. C is also quadratic. Okay, next three, we have linear, exponential, and linear. So hopefully you guys got all those right with no issues. All right, number two, given the scatter plot below, which of the following equations would best model the data? Explain your choice. Okay, so you can see when you connect the dots that it is a quadratic. Okay, so that means 1 and 2 are out. 1 is linear, 2 is exponential. And now you have a negative and a positive A term. So remember, negative is like a sad person, so your sad face. And positive, you're a happy person, so a happy face. So this would be opening down, so that would be C, which would be your negative 4x squared. All right, on the back, we got one big question. So a marketing company is keeping track of the number of hits that a website receives on a daily basis. Their data for the first 2 weeks is shown below. A scatter plot of the data is shown. So you have your information, and then you have your scatter plot. Okay, if you kind of connect the dots, like in the front, you could see that it kind of looks like a line, but I guess it could also be maybe exponential if it continues to go up like this. So of the three types of regression we have studied, which one seems least likely? Okay, so I just mentioned the first two. I mentioned linear, and I also mentioned exponential. It's definitely not quadratic. The y values do not increase and then decrease, or vice versa. It's just increasing. So that would be either linear or exponential. So for the next part, part B, it says find a linear equation and then also an exponential, which makes sense because we said this could either be linear or exponential, and we're not sure. So we do a little information. So your linear, remember, that is number 4. Okay, after you put all those numbers into stat 1, okay, put all the numbers in stat 1, you're going to go to stat calc and then 4. Stat calc 4 is your linear regression. You should have gotten 10.83x plus 114.07. Then for the exponential, remember you put those numbers into stat 1, L1 and L2. I know those aren't the right numbers, but just to show you. And then press stat calc, and then you go down to 0, which is exponential reg. And that's how you get these numbers, 121.09, and then times 1.06 to the x. I also copied down the correlation coefficient, 997 for linear and 999 for exponential. So that means, even though they both work and they're both really good, exponential is higher, so exponential is the winner. So this is going to be an exponential graph and not a linear. So for part C and D, this is the only part you might have been a little confused on. How close are the two models' outputs when x equals 10? So basically you wanted to do each equation. And then for each equation, wherever you see an x, put a 10. Here you get 222.37. Here you get 216.85. And then the same thing here when x is 30. Here you get 438.97, 695.48. So you could see here it's a lot closer, but here it's a lot further away. So in the beginning, it might seem that it's linear and it might seem that it could be exponential, but as we go further, instead of going straight and go constant, it's going to really curve up. Okay, it's going to really curve up. So that's how you know they're not so close together. Actually, let's quick graph this and see if you can see it from that as well. I'm not really sure. So 0, 3, 5, 10, and 14, and then 120, 145, 162, no, that's not right. 162, 220, and 270. Let me turn on my stat plot. And then go zoom 9. Can we tell? No. So we get the same exact graph as we do on it. I thought maybe we'd be able to tell. What about zoom and fit? Can we tell from there? Nope, that's from another graph. Okay, so says which model will predict faster growth of website hits over time? Explain your answer. You may want to experiment by graphing both models. So basically, this 100% will grow faster. The exponential model will increase by a faster rate. Proof is an example above. So you can see right here that when the numbers are lower, they're closer together. But as we get further, on, this is definitely going to increase a lot more. This is 439 to 695. And that's what an exponential does. You know, it exponentially increases very, very quickly. So, all right, hopefully that helped. Hopefully you understand everything. If not, just let me know. Ask me any questions you have. And don't forget to post it on Google Classroom. Thanks so much.